Hey everyone, welcome back to the third part of the Introduction to Sorting Algorithms video. In this part, we'll be familiarizing ourselves with merge sort and quick sort. We will understand what are exactly merge sort and quick sort, also exploring the working procedure of both the algorithms and what are their advantages. This is our agenda for today's video, and after this, I'll be coming up with videos for in-depth analysis of all the five sorting algorithms that we have discussed till now. That is bubble sort, insertion sort, selection sort, merge sort, and quick sort. So make sure you hit the subscribe button and press the bell icon so that you never miss an update of upcoming videos. So after all this, let's get started with our today's video. So by definition, merge sort is a comparison based sorting algorithm that follows the divide and conquer strategy. This is a very important terminology you have to keep in mind. We'll be discussing about it in a short while. The algorithm's primary goal is to efficiently sort arrays by dividing them into smaller subarrays, sorting these subarrays, and then merging them back together to produce a fully sorted array. So this divide and conquer strategy is based on two pillars. First task is to divide the original array, and the second conquer is the merging of those divided parts. At last, it produces a full sorted array. Let's understand it with the help of an example. So over here you can see an array, and over this the divide and conquer strategy has been implemented. See, this is the original array, this is the intermediate state of the divide and conquer strategy, and this is the final state of the divide and conquer strategy, right? So in this part, what is happening? The entire array, this entire array is getting divided into sub arrays, and after complete division, we would be having this intermediate state where each sub array would be having just one element. So this is the intermediate state after complete division. After this state, the conquer strategy takes place. The sub-arrays would start merging among themselves, and the final result would be like this, where each element would be sorted. So this was an overview of divide and conquer strategy. Let's move further. So the same thing has been written over here, what I explained in the previous slide. First is divide, where the entire array first gets divided into two equal parts, two equal sub-arrays, and again those sub-arrays again gets divided into two equal another two sub-arrays. Means now we would be having four sub-arrays, and this division would take place until our intermediate state is reached. And conquer part is basically the merging of those divided arrays in sorted order to achieve a sorted array, sorted final array. And this conquer procedure takes place recursively. Merge term refers to the merging of those sorted half while ensuring the order of elements is preserved. Right, let's move further. So here are some advantages of merge sort. The stability. Merge sort is a stable sorting algorithm. It means that it preserves the relative order of equal elements. If you haven't seen my recent video regarding what are stable sorting algorithms and what are unstable sorting algorithms, which is a quick 2 minutes video where I have clearly explained about the stability of sorting algorithms. If you haven't watched the video, make sure you watch it. I will attach a link of that video in the description. You can watch that video after finishing this video. The second advantage of merge sort is predictable performance. It means that merge sort maintains a consistent time complexity of O of n log n. It means that the time complexity of merge sort is always going to be n log n. So this quality makes it a reliable choice for sorting large data sets, right? The third advantage is parallelism. So this term in computing means that several operations can be performed at the same time. This is the meaning of parallelism. So divide and conquer nature of this algorithm allows us for efficient parallel implementation, leveraging multiple processing cores. It means that there would be number of operation sites created at the same time to perform the task, right? So these were the advantages of merge sort. Let's move on to quick sort. So here is the definition of quicksort. Quicksort works by dividing and conquering the input array. Again, divide and conquer strategy has been used in, but the methodology of quicksort is completely different to that of merge sort, though they both use divide and conquer strategy. So it first chooses a pivot element. Mark this word, pivot element is going to be very important in understanding quicksort. In fact, it forms the base of the entire quicksort algorithm, and then partitions the array into two subarrays. So the partitioning would take place around the pivot element. All the elements that have value less than of pivot, they would be arranged on one side of the pivot, and all the elements that are having value greater than that of pivot would be arranged on the other side of the pivot. So there would be two subarrays created. One subarray would be consisting of all the smaller elements, and the other subarray would consist of all the elements that are greater than that of pivot. And this process keeps on happening recursively, meaning that the subarray that we have got, again we would be picking up pivot element in both the subarrays. So the same procedure would be followed recursively, and the result would be a sorted array. Let me explain you how it works. So I am given an array. Out of that array, I pick a pivot element. I can choose a pivot element in number of ways. I can either take the last element, the middle element, or the first element. It completely depends on me which element I choose. So I would be picking up a pivot element, and now comparisons would be done between all the elements of the array and the pivot element. Every element that is having value less than that of pivot would be arranged before the pivot, and all the elements having value greater than that of pivot would be arranged after the pivot. So now a sub array would be formed of elements that are less than that of pivot element and elements that are having value greater than that of pivot element. So after one partition operation, we would be having this scenario. Again, partition would be performed separately on this subarray and the other subarray. Same procedure would be followed on both the subarrays. We would be picking up a pivot element in this subarray, again getting two subarrays of this S1 along with the pivot, and two subarrays of this S2 after the procedure along with the pivot. So this process goes on recursively. So this was the basic understanding of quicksort. So after this, let's understand the steps involved in working process. So firstly, we would be choosing a pivot. The array would be given to us, and we would be choosing a pivot. You can either choose the last element of the array as the pivot, or the middle element, or the first element of the array. It completely depends on you. Second one is partitioning. This is same that I have explained you just a while ago. After this, recursion would start playing its part. The same partitioning method would be implemented on the subarrays obtained, and after this combine, we would be combining the sorted partitions, which would result in a fully sorted array. Let's take a look on some of its advantages. So the first advantage is efficiency. Quicksort's average time complexity is big O of n log n, which is better than many of the sorting algorithms. But the point over here to note is that this time complexity is not consistent. Worst case time complexity of quicksort is big O of n square, unlike merge sort, about which we discussed just now, which is having a consistent time complexity big O of n log n. But still, it is better than many of the sorting algorithms in terms of time complexity, which makes it a preferred choice for large datasets. The second advantage is adaptability. It means that quicksort is considered an adaptive sorting algorithm. If you are thinking what is an adaptive sorting algorithm, so an adaptive sorting algorithm is one that takes advantage of the existing order in the input data to improve its efficiency. So quicksort can be optimized for partially sorted arrays, adapting its behavior to the input data. So this ends the brief introduction to quicksort. So now we have completed our introduction part to sorting algorithms. After this, I'll be coming up with videos having full explanation on each of the discussed sorting algorithms. So thanks for watching the video. So see you again in the next video.